Hi guys, my name is Mark and today I will show you the first video of a very long way to the dark side of the latency, guys. The first BIOS UEFI for AMD based CPUs of the Zen 3 family. Let's go. As I said already, today I will give you a brief and short overview about the changes I'm doing or I have done to my system, which is basically a 5950X, which has basically normal binned cores and is equipped with G-Skills with CL14 timings, 3800 megahertz. And I'm using a 3090 right now before the 3090 Ti is coming out. And in the last year, especially in December, I spent a lot of time about searching and researching for the best UEFI and in general settings to have the lowest latency and the most responsive system possible with my Asus mainboard, which is only Hero, not the Dark Hero Extreme or whatever. So it's a mediocre, normal level Asus mainboard with a X570 chipset for AMD Zen 3 family CPUs. And today, or like 3 days ago, I updated the BIOS to the version 4004, and that's not 405 or 6, which came out yesterday, which is basically already for the 5800X 3D. It's the version in before, but it uses the same gears, so there's no problem and no real big changes. And I just will show you the settings I would use to have the lowest latency. Up front, I want to say basically my system is kind of good cooled. I'm watching basically everything and I tested a lot, and this is not the way you should can do it on your PC. For example, if your power supply is not that good, if your cooling system is not good, your water cooler or AIO is not that good, you maybe cannot do it and you maybe damage your PC, okay? So if you damage your PC by anything I'm showing here, that's basically your own fault, because I'm only showing you what I'm doing. That's not what I would say or would recommend anyone to do. I hope this is clear for now. So I'm just starting. In before I already recorded the German version, which was like over an hour. I try to keep this a little bit shorter for you because I will keep the trash talking about some stuff. And I just resetted the BIOS to 0 to the standard settings. And we just start here. I just set it back from German to Korean. No, I just set it back to English. And then we just start here. At very first, as you can see, it's right now running, the CPU is right now running with 1.45 volt on the CPU. That's kind of high. Maybe good for single boost cores and for OC and curve optimized settings where you are about to have high clocks like 5.05 gigahertz or something. This one, also my first CCX, the stronger one of both, is able to reach 5.25 gigahertz on 6 cores while it's playing with precision boost and with the curves optimizer on the right settings. But to be honest, I tried this a lot, I played this a lot, and I also used Hydra for a very long time, which is a great program, but basically for gaming it's insufficient because of the switching of those of the modes the whole time. That's why I decided to find a way to make a very good all-core overclocking with very awesome settings. So as I said, 1.465 volts right now, the core voltage, the block is like it should, 100 megahertz, and we stay 100 megahertz, guys, don't worry. The temperature is already kind of high, 45 degrees. Normally it would be 50 right now. After my setup with an all-core OC optimized for latency, it would be 34 to 36 degrees Celsius. So we just start. The very first thing you do, or I do, is setting the DOCP Sorry, it's kind of, the booting is kind of sensitive to my fingers because I set the points very high. So you just set it. What is DOCP? It's basically the AMD version of XMP, so of those optimizing overclocking feature for your RAM, so for your memories. I'm using 4 memories, so all my slots are like set up. So I have 2 dual kits inside. All the same, all from G-Skill, B-Dice, CL14, as you can see, 14, 16, 16, 36 settings, PC 3800, they're kind of very good. That's the Neo series. I would, if you want to use G-Skills on your AMD, go with the Neos. They have a different chip for the control and for the management, and also the voltages are a little bit different. I tried in before with the absolutely comparable non-Neo versions. We tried together with my cameraman when we just set up this PC first, and they were running poorly. They were not running with DOCP XMP settings because they're just crashing. They're crashing the whole time. Sometimes your PC don't even start. So just keep in mind, if you go G-Skill, take the Neos for your AMD setup. So we're doing this. DOCP settings are set. Memory frequency is set basically. As you can see, then we go for the clock, and we just put it down for a 1-on-1 setting. We just put it down to 1900 megahertz. Basically, AMD would recommend you to go down to, I think, 1600 or 1800, depends on which RAM you're using, which memory. AMD, when they released this group of CPUs, they said you would profit more from lower clock timings than from those high hertz. Right now, I know you're also, or you would be capable to run 5000 easily with a CL14. So no problem here. It's working, and it's working since day one I have the system. It's working like for over a year, more than a year, huh? More than a year. I think December 20 I set up this PC, and since then it's working like this. So core performance boost, we're working later on. We just now set it this, then we go over, we save and reset. It's done. You see a blue screen. The reason is because I'm capturing with a second PC, and it's a loop through, so it's just a pass through. And over there I see the picture before I see it here, for example. I'm already in the BIOS. It takes it some time now. Give it a second. Here we are. As you can see, it's still English, it's still working, as you can see, and it's 1-to-1 and working. Voltage on the memory is 1.504 volt. We will change this later. I explain why also. We still kind of high. So we just disable the core performance boost. Yes, we disable it because we will not use any PBO advantages or curve optimizing or whatever controls. We just go with a very, very good core per CCX ratio. For this, I would, I just tell you what I'm doing. Basically, I choose something between 1.29 and 1.32 volt, which working very good for me. I'm basically will go now for 1.3 volt. I've done this in the German version too. Then I'm going for kind of conservative, so for like low numbers here. Mostly, or if you're not tested or checked your CCDs, basically all the time your first CCX, the CCXO, is the better one. Basically, for me it was like, this one was gold, and the CCX2 was, so CCD2, CCXO, so it's called CCD1 here then, was like silver, and the strongest and fastest and most efficient cores are on my first CCD, and just by pure understanding of CPUs, so you try to give the workload to the stronger and more efficient CCX, so you just do it on the first chiplet. You have at the 5950 and the 5900, you have like 2 of them. For me it's 8 cores and 8 cores, and the first one is stronger, and I can run with 4.725 gigahertz, but basically Right now I'm running with 46.75, and on the other one I will go more down, because the main problem here is when I use Tidra, I've not gonna lie, I raised the voltage way too high on all core usage, and was kind of dumb to go in 1.35, 1.4 volt on all cores. It's super stupid, don't do it, guys. Try to avoid this, and at this point I just destroyed one of the cores, or basically I do not destroy him. The cores just breaks in when the clock is getting too high, and the voltage is over 1.29. So I just avoid this, and I know what's the limitation of this. I'm going to 45.25. That's basically 4525 megahertz, so 4.525 gigahertz. And that's the settings which are working very good for me. These settings are enabling with the 3090. I've used an Apex between, my average is above 299 FPS on Full HD, and on 440p it's still above 270 FPS, unlocked limiter, and it's super good, super responsive, very low frame times. Everything is awesome, guys, and I can tell you this works for me. So we just set up the voltage and the clocks per CCX. So for the first and the second one, this setting here, core VID, is overwriting this one here, so you can leave it on auto. After we restart the BIOS once, this one will change. Just to let you know, because I know people then ask, but why you don't change the core voltage down there? You don't need to, because this overwrites this. So, okay, we've done this. We can go for a TPU for nothing. Here you can choose none, for example, because you don't use TPU. TPU is like the tuning tool from ASUS, and you don't want to use any tuning tools by ASUS, believe me, guys. It's just brainless tuning for people who have no idea, and at the end will be a result you don't want to have. That's basically all I can say to this. You disable the PBO FMAX enhancer, which is which is maybe good to support high frequency at single loads, but we will not have any single load here, so we just deactivate it, disable precision boost overdrive, disable, and that's it. The rest can stay on auto because it's disabled anyway. You go into the DRAM settings. I know a lot of you would like to switch here some stuff manually and make your own voltages, settings, whatever. You can do it. I keep with DOCP settings because the way I do it, I go for roughly 50 nanoseconds on the AIDA bench for the memory throughput, and that's kind of fast, I'm not gonna lie, even if you compare it with your system. And it's just with those standard settings. I just go power down, disable. You can go gear down on auto. You can choose 1 tier or 2 tiers you want. I stay on auto here. That's everything I do here. I don't change anything else. Nothing to do here. DOCP settings just working fine. And I also don't use memory presets or something else. That's it. It's for the DRAM timing control. Then this will be like more extended now, and I also explain why. For those of you who are have more knowledge about this kind of BIOS by ASUS and about PBO and curve optimizing, and what we're doing here right now is that basically this one should be disabled by just the pure way I'm overclocking right now by those fixed clocks by CCX. But to be honest, those load line calibration settings, they are still somewhere in the background, and if you just put it on auto or too low, it feels like the stability of the system is not that good. If you like set it to real values, which would be fit to those to the numbers you have set in the cores, so in the CCX 0 and 1 settings. I'm just setting it up right now and explain it a little bit. We stay on the voltage monitoring on die sense, not on socket sense, and because it's both dies there, you know. Load line calibration is like, normally people would tell you go for level 3, It's kind of secure, it's also good. We just go for level 4 to have like, if it is really there in the background, enough power, so enough voltage at this point for those nearly 4.7 gigahertz, which is basically those, a very good number for those Ryzens with 8 cores on every CCD, on every CCX, and we stay like this, level 4. Then we go to the current capability options. We go with 130%. Why? Because we want the power and we don't want to have something cut off. This is the option you should go also. So if you not want to use all core OC, you also should go with those 130%. It's kind of good. It's working basically also on level 3 load line. If you're not all core OCing like we're doing right now, then you go with those VRAM switching frequency, you set it to manual, you go down there, then you can read down your frequency range. I basically go like always 50 kilohertz below the max. Keep in mind, the lowest kilohertz here is the low end switching frequency, which basically means is the most efficient, but and also the least heat providing, or just it gives the least heat because there's the least power going over, and so you have the least thermal problems if you go like this. If you have, for example, a hot environment, or your cooling is not that good, your PC is not that good, in general your airflow and the way you cool your system isn't that good, you maybe stick with 300. I'm going here now for 450. I also tried 500 kilohertz, and to be honest, for most or for some people this could get very unstable. As I told you, the lower ones is lower switching frequencies and lower temperatures, and the higher one is higher temperatures, higher frequency. Some people can hear it if the mainboard is not that good, for example, and it's maybe, or it can get annoying, but I tried 500 kilohertz and it's not better. Sometimes those 50 kilohertz less was way better than the highest switching frequency. Can't explain you why. I think that's basically the boundaries of how the keyboard is, the mainboard is made, the keyboard also. And I think staying a little bit below the boundaries is always good for those products, even they are not super enthusiast or super high level. We stay here with T-probe because we want to have it like thermal balance, not current balanced. Current balance we could go if we have really good cooling, so just stick it with this. You go over there for extreme mode now and the power phase control of the CPU. Yeah, now you ask me, but some people say I should go with power phase and ultra fast. Yeah, you should, or you could do it if you're using your C and P stats. So you use those, the energy management of the Windows, for example. So you trying to save some energy at some points. But what I'm used to do, so what I basically do, I just optimize the system to run at one specific setting, which is very fast, very low in latency and very responsive. So that's why we are going here to extreme, which is basically full phase. So all of them are working. There's no switching, and we just keep it like this. Everything is used. All phases are used. That's what we do here. Thermal control, we just stick with the setting. You don't need to OC, tolerance, enlarge, whatever. No need, just stick with it. We go to the load line. Basically, my tip here is people say you just only do load line 1 because the socket and all this stuff and around. You just basically always go one level below the CPU load line calibration. Some people just go 1.1. For myself and for my understanding, it's not necessary to go to the same levels. The voltages are not the same anyway, and the voltage behavior here, so I just stick with 3. It always works. It's super, it's not crashing. It's only crashing if your cooling system is insufficient or is reacting very slow while it comes to high keep loads, for example. So the switching frequency, we always go to manual, as I said. Here you can see the max is 600,000 kilohertz. We go with 550. That's it. Phase control, you just go extreme. As I said, you don't need to go power phase, ultra fast, you just go extreme, full phase. Then we are going to the DRAM capabilities. You just set 100, or I just set 130% because I know this one is easily capable of this. It's not even getting hot. The hottest temperature I've ever measured was like 41 degrees on this memory. The phase control we set on full phase, like always. And then we just set the switching frequency. You can test here a little bit for your own RAM. For me, 450 was the best. I tried 400 kilohertz. It was way worse, to be honest. I have no clue why. It introduced a lot of latency. So this one was the best for me and I will stick with it. When I went to auto, it was also not that good. I have no idea what the auto settings are or how variable they are, but this one was way the best setting for me. So we just finished the extreme tweak external Digi. So basically the power settings we have to do. It's all here, all in this one like little part of the extreme tweak, and it's very good, very well made, good explained, and I think that's all you need to do. There's nothing else or extra you need to really to have in mind or just watch for. Then you go Triggers Paradise. We just go there. And this is one very important thing here. I know there are people out there who tell you you need to enable clock spread spectrum because it will help your system to perform better and whatever, and your RAM. And the problem is it can be true, but only on systems who are switching those modes, the CMP states, very often, and we will not switch them anyway on any point. We just set them to 0 all later. So we want a stable clock of 100 megahertz. We don't want 99.1, 99.86 or 88.9 or 100.25 or whatever. Just want plain 100. That's why we disable this. Bam. That's the best you can do. Just disable this. Don't leave it on auto or enable. Please disable it. Also, we just doing this for the best performance. And as I told you, stable signals, stable clocks, everything stable on one setting. So we just went down here to the very bottom. The promoter represents, you just disable it. Why? Because I only use 4 USB ports and I don't use anything connected to the south bridge. No controller, no ports, no whatever. Just go there with disable please. Then something very important for you as a gamer and in general for your peripherals you're setting there, or for USB or anything which is related to you, to input or whatever, or to the in general communication of the whole system. You just go here and set the amplitude to high, please. Why? After doing this, you just can do it on the system you're using right now. Don't change anything, only change this. You will realize when your USB is set up right here also that, for example, the sound changes on your USB sound card, the behavior of your keyboard changes, and the behavior of your mouse gets more accurate, more exact. You can use mouse tester and you will realize on mouse tester that your DPI spreading is way lower and your latency and sensor movement is more favorable, more one-to-one. The reason is the amplitude gets better, higher, and the everything connected to the PC and in the PC is like not more reliable. How can I say it? It's more easy for them to see or register something when something happens, when there's a lot of traffic on the bus. That's the easiest way to explain it. Maybe not 100% right, but just for you, for the understanding. That's basically it for now from the Extreme Tweakers Paradise part. So as I said, we've done this here. One thing you can do, or what I do, is you see that basically the DRAM voltage has been changed just by the DSP setting we have done. And one problem, or one thing I would say you should do also is, like, you go into the manufacturer of your RAM and you're just checking there exactly the one you have, which voltages it is capable of and which voltages is running best. And I know those DRAMs they've using here, they can just run up to 1.55 volts. And it's just set to 1.5 and it's right now 1.504. But sometimes, just by how the board is made, it goes down to 1.49 and 1.48. And at this point, the latency and the way the DOCP is working for this one, it's just totally trash, and you really feel it that it's like the flow is just destroyed directly. That's why I always go for 1.51 volt. And this always keeps me above 1.50. Always. I never go down. That's most important. And with these settings, I have very, very good latencies and workloads, and everything is super with this one. You can just test it for yours. Also, don't go too high. Don't just do like 1.55 or something. Or if your one is 1.4, don't go 1.45 or something. Okay. Just give me a second. The CPU voltage, the core voltage will change after we have restarted, and the CPU core ratio per CCX is set. It's got overwritten, and it goes down from 1.457, which is kind of very, very stupid high. Not gonna lie, I know it's capable of, but it's totally useless. Yeah, that's it for here. The extreme tweak is just finished for now, and we just go over to advanced. We just start with those trusted computing, and lately there, as you already know, AMD also confirmed it. Now there's some problems with those security modules, or the built-in way of the security models with those CPUs. If you just don't use external security models like ASUS is sending you those little sticks you can plug on your mainboard, you can just go with disable for your Windows 10 system. You can do it. I saw a lot of videos yesterday and I checked it, and there's really literally a lot of micro stuttering, even if you have a very, very good system, or you just kept your FPS for like only 15% workload or whatever. It still can occur that you get those micro stutters caused by the setting. And if you're using Windows 11 already, honestly, I've never used it, and I think I will not use it right now or in the near future. I know it could exclude you from updates if you disable this just for pure performance. But I don't care. I just go with disabled. And you know, TPM 2.0 device found, but I just disable it. And here I just go for the discrete TPM, which basically would be the one I told you from ASUS, but I don't have it, but you don't care because I don't, so I disabled it anyway. CPU configuration, kind of important for now. Don't touch CCD control, don't touch core leveling. You don't need core leveling to get the lower latency, just disable it. We go for SMT mode, disable Y. I have two CCX, also two CCDs on my chiplet, which are basically 2 8 cores, and I don't need 32 threads for gaming. I want very low intercore latency, so the connection or the latency by providing data between cores 1 to 16 is way, way lower from 1 to 24 or something like that. You can check it on some diagrams if you want. Just go with this. This is real 16 thread, no virtual threads setting. So you disable the multi-threading, the virtual thread mod. We stay with SVM mode disable because we don't use virtual machines. The rest we just stick with. There's no P-state adjustment needed. PSS support also enabled. We just go out there. We go into the serial ATA configuration. We just press disable. Why? The reason is we don't need anything of this. We just use our discrete NVMe, which is connected over PCI Express 4.0, or we just use a DIMM module, which is basically close to our RAMs, which sticks or contains also an NVMe SSD PCI Express 4.0, which is in this case the Samsung Pro 980, so the Samsung 980 Pro 2 terabyte, which is working very good, guys, very fast. with over provisioning and with those enhanced performance settings. But about this in a later video. Onboard device configuration, kind of important too. We keep it like we already have done. We just disable everything we don't need, and it's 2022. Please buy a DAC amp stack, buy a G6 Sound Blaster, something external connected over USB, please. Please disable sound on your keyboard. Thank you. Then we just go with the bandwidth modes. Here we just stay with the auto mode because we don't use the RAID mode here on our first and second PCI Express 16 connection and connector. We go with the RGB lighting. Ciao, I don't need RGB. So all the one here you see, which is also connected on the RO, the water pump, the Alpenföhn, will switch off later when we just finalize the settings. Also, I don't need those right here, pack, whack, it's away now. We disable the Realtek 2.5G LAN controller. Why we do this? Because we don't need it here on this board. I'm not using anything related, or there's nothing like file sharing or so on this system. It's pure gaming. And the Realtek one here on this mainboard, on this setup, is integrated over a controller. And okay, you can use like 4 RSS queues, but why should I do this when this bad boy here from Intel is just directly connected to the CPU, straight with an own PCI Express connection, which only needs 2 RSS queues, has super low latencies, super low interrupts, and everything is working really, really fast, really controlled, real stable ping timings, and real good throughput while it's this. And you can use all offload features here. That's kind of nice. We stay with the Intel. It's not the fastest, but it's okay for me. We go with the ASM controller. We just disable it. Why? We don't need those USB ports down there, those external connectors. We just need, I don't need anything, which this one is controlling. And it saves you a lot of traffic on the I/O and in general on the transfer lanes around the CPU, on the bridge between the Nord bridge and the CPU and all the other controllers. So we just keep with this. You just have those S5 state, soft off state with the power delivery on because you want to charge your gear. You can use Gen 4 here if you want to. This is your PCI Express 16.1. That's the upper slot where you normally install your graphics card, and I would tell you, or just would say, if you don't use this slot, please switch your graphic card to this slot. It's just in how the architecture is made on mainboards, the best way to connect your graphics card to your CPU on the bus. So on the PCI Express bus, you can leave this to auto. That one is the very small slot you can use, but this, I can tell you already, is also the same line the Intel card is using. So the LAN adapter is using. If you put something in there, you will get problems, guys. Just don't do it. As I told you already, buy a G6, buy a FIO DAC, buy a Zen DAC, whatever. Just buy something you like and enjoy. Buy shit audio, a Fuller or a Hell or whatever, guys. Don't use anything related with sound on board. Don't do it anymore. Makes no sense. Just we go down here, then we go to the M2 links. Both devices are connected over the PCI Express bus. And that's the Southbridge link, by the way. We don't need to check it because we disabled it. So you go for Gen 4 here too if you want to. If you have a Gen 4 NVMe SSD inside, that's okay. We are done here. We just disabled everything we don't need. Then we go to the APM configuration. We don't need to change anything here. PCI bus system, we go above 4G decoding and resize bar on auto, because we have a 3090 card. It's resize bar. It's capable of doing or using the resize bar, so we just want to have it enabled here if you need or want to use it. Then we go into the USB configuration. We disable those legacy ports. Now you say, yeah, but I need it. Okay, if your device is so old, or you want to connect something like with an input, like old external CD player or whatever, you can just enable it for the time. But in general, please just disable it. You don't go for auto, please. I know your auto says, yeah, but auto it says disable. It's automatically just disable. XHCI handoff, please disable it too. Why? If it's enabled, it's like there is so disable is saying your mainboard is handling everything for those devices which are connected, which like you can there USB controllers, 3 XHCIs, and if you have it on, Windows is doing it also or mainly. And I can tell you, if you use optimized Windows with very high rates and no C states, it kind of gives you a weird feeling. You get those fast overshoot feeling, like you have your mouse enhancement, movement enhancement is enabled, but it's not, but it feels like this. So just go with disable, that's the best setting. Then we go into the single port control, we just disable anything which is not connected and used. That's it. Snack. We just go out here, that's done. Network stick, we don't need the network stick because there's no external entry to the network. I don't want to get from external entry to my PC over my network. HDD device, non-connected. NVMe configuration, everything okay. We go here, we enable data link feature. We just go back then. We go into the AMD overclocking. We don't need to manually overclock, we've done already. We don't need to set this, we have done this already. We don't go into the echo mode because it's disabled. You can just check this if it's really disabled. If not, please disable it. We go into the precision boost overdrive. We disable it again. Yes, we disabled it already, but to be sure, basically most of these settings we have already done under the extreme trigger, but we've of some of them, to be sure, we disable them here also. The LN2 mode, you don't need to do something because it's basically managed over 3 pins and the connector on your mainboard itself, and I don't think you want to do some nitrogen or something else or extreme cooling to overclock your device or basically your system, and you want to break some records with your hero mainboard. SoC voltage you don't need to change. You uncore, yes, you uncore. Why you uncore? Because you want to have every peripherals, every bus system, every connector, every clock related thing to run always at the highest settings and clocks. And you can check this with CPU set, for example, or with those CCP it's called. You just can double check if it's really like this. It says uncores and shows the uncored clocks. That's really good, you want to do this. The VDDP voltage you don't need to set, we've done this. Also now something very, very interesting to really reduce latency, guys. Basically that's a feature made for those, the Ryzen, how they call it, those thread rippers and stuff. So basically for everything above 16, 24 cores, also for the epics and something like that. And the real stuff you can find about it is for data center usage, and it is about throughput and latencies. I can tell you one thing, those number nodes per socket is basically the alignment and the understanding how it's managed between your RAM and the RAM management, so the cache to RAM data transfer, and how it is addressable and how it gets addressed. If you stay on auto, I have no clue what happens, to be honest. If you stick to 0, it's like all 16 cores on my 5950X are 1. If we go with 1, it's 8-8. If we go with 2, it's 4-4, 4-4. And if we go with 4, it's 2, 2, 2, 2, 2, 2. Okay? So for me, the best is like 1 or 2. 2 is basically very nice. If you go for 1T settings, then you just go with 2, and you have 1T on all 4 RAM banks, and it's kind of fast. But one thing I can tell you, as the latency gets lower, the throughput in general, while it's rendering or something, will get worse. But you disable SMT anyway. So keep in mind your multi-core scores will not that great, to be honest. You just locked your CPUs, frequencies and everything. So some of your benches are may not that good after this or after the tweak, but the latency, guys, will be nuts. You can believe me. So then we go to the clock. What we're doing here is we just disable it. Why we want to disable it? Because as you can see, disable is a fixed alt clock. Why you want to do this? Because you don't want to have like power down, gear down modes on the clock, on the bus. You always want to have the communication set to the same level. And if there are no changes, you can't introduce latency. That's it. Now we were in overclocking, now we go to those common settings. We start on top now. In German version I started from the bottom, and I forgot one of the most important here. It's here in the first. In performance, you don't need to make any custom states because we just use PO, which is already set by the CPU common settings. Then we go to prefetch settings. You want to prefetch everything, all hardware settings, because the addressing, the capabilities, the basically how the system reacts, if it's like pre-cached and known, how the distances are, how the behaviors are, how the bus speeds and everything is set, it helps you and the cache to basically just have better register timings and to control the flow. I say it's a flow, okay, to control it. So just enable the prefetching, please. You don't need to do anything on the core watchdog. No need to. You go for performance boost, disable. Now you disable the global C states. Now some people will say, yeah, but those NVIDIA, AMD devs in this one, in Germany called Kaffeeklatsch, where they sit together and talk together in the podcast, they say C states are most important, this and that. If your system, like we're setting it up right now, will run better with C states than without, you have made something wrong. Can't be. Also, if you're using Hydra and you're doing this, Hydra will not run anymore because you can't do anything. And if you do some benchmarks, guys, with Hydra or something, it will reset all the settings, by the way. So I can tell you some of the benchmarks which are using C states will maybe reset some of the settings we are doing here right now. So keep this in mind, please. So C states off, power supply idle control, typical current idle, please, because we always want to be capable to do what we love and let the PC work like hell. We don't need to set this, we don't need to set this, we don't need to set the streaming core. The APEC mode don't need to be set because 2 is for systems with like so many CPUs and connections you can't imagine. You could do this one, but you won't, you just do auto, so it decides itself. You disable the C1 declaration in Windows for the C1. Yeah, I would say like it's not the full, so it's directly below the full power mode, below CO. For PO, it's like the first way or first point of saving some energy. Just disable it. The rest you can leave. That's all good here. Nothing more to set. We just go back. We go to the DF common options. You don't need to do something in the scrubber. And the memory addressing, you can go with your NUMA settings again if you want. You can just do it. As I said, I've done 2. You can test with 1 at first and try for you, and later you can go with 2. 4 is kind of only if you have like 16 or more cores, in my opinion. The memory interleaving, you just leave on auto. The size you go for 512 bytes. That's kind of good. You don't need a remap, and you don't need the map inversion of the RAMs. That's all. This one here now you say, oh, but there's NUMA again for domain and the cache for the accuracy. You don't need to. One thing is here, if you used this to enable it, it basically is the addressing of the cache for the cores and not the memory addressing by the amount of NUMA you have set on the CCD side. So this one would manage it then, and then it's only just like NUMA 1, so every CCD is one-time addressable, and then I think it's most likely to go to 2T, so to those double channel way on the RAMs, and it would be a little bit slower, there would be a little bit more latency, but you would have more throughput. I would do it if you go into CPU bottlenecking, but I have no clue how you want to go into CPU bottlenecking with a 3090 or later 3090 Ti or like a 40 card end of the year. I have no idea, guys. Even if you run super high, maybe in Valorant, but then in Valorant I had like 1250 FPS, and when I stand on bind on spot and watching down, it was to the Brunnen, called in Germany, to the well, it's like still 650 FPS stable. What do you need more? So just do like keep this on disable, please, or just keep it on auto, because you set the numbers anyway, and you won't do it on enable when you set numbers. The link here, you don't need to change something here. Disable external DF, you don't need to. The float is also an unnecessary lows. And one thing which is really important now is those clearing of the memory. You just disable it. Why you want to disable this? Because we will use those training modes for the read and the write training between those numbers we have set and the RAM they are using, so they know how is the fastest access with the bytes we have set to enter and to just interleave, so that you have the fastest and most low latency communication. And for this you can't clear the memory, because if you do this on every restart, everything they trained is lost. So just disable this, please. You go into the UMC options. Basically there's, besides those physical configurations where we just set those training right now, there's nothing more to do, to be honest. You can, some RAM gurus tell you do this and that, but I've tried a lot. I've tried the whole December, a lot of shit every day, like 4 to 8 hours, nearly every day, and there was nothing which was really like the where I thought, wow, that's it, nothing. That's good, just keep it this way. It's stable, it works, it's fast. TSME you don't need to, because we disable it anyway. Data poisoning, there's nothing to do. ECC configuration, nothing. All good here. Data bus configuration, keep auto. This one you already set on the extreme tweak settings. You just can keep this here. DRAM timing configuration, no need to do anything here because it's everything set already. The mapping, yeah, no, that's the DRAM memory mapping. Sorry, I thought I were there already, but it was on the video before. It's like those video kept 1 hour and 11 minutes. It's kind of long for a video for me commonly. Then we go into the Northbridge IO common options, and it's between, yeah, it's for the communication in general. The IO you don't need to set anything, to be honest, just leave it on auto. I know there's a lot of people who say, yeah, just disable it, that's not a multi-core, blah blah blah. Just keep it auto, please. This one is kind of new in this BIOS. I did not check it already, I will check later, but I don't saw on the first watching that there will be any advantages. XFR enhancement, no need to change anything here. Basically you go into the SMU common options. We start in the Northbridge IO clock. We just set it from auto to manual. We go there all with level 2 because that's all the highest possible clock rates. 600 MHz for the IO communication. On the Northbridge side, it tells you the socket and the targets, and you just want to have the fastest one always. The prefab cores you just set to enable. Now some people say, yeah, but it's only if you use those curve optimizer. Yeah, that's not true. Basically, it's just the general way how the communication is and how the setting is made by AMD for your CPU, for the control of the for the workload for the cores. He knows, or with the settings, the cores are preferred, some of them which are working good, low voltage, high throughput, low latency, and these, or in general, then when the workload is rising, by the setting, the preferred ones, so the good ones get first and the worst ones get last. That's what you want, course, low latency, good throughput, nice performance. We go with C states disabled, please. Then we go with the APBDIS mode on 1, because we want to fix the SOC P states to PO, and then the SOC P states are fixed now. You don't need to set package power limit. Some people say, you just set it to 120 or 30 or whatever. You want it stable, you don't want high temperatures, you want to avoid temperatures above 60 degrees because of throttling and of thermal. And so if the thermal stress is high, voltages are fluctuating also. That's the same for your graphics card, by the way. So just keep it cool and just stick with auto. Everything else can stick with auto too. Then we just go down here. Nothing need more to set. You don't need to prefer an I/O. Basically, that's it here. That's the magic. I know this already took kind of long, but we have done here. On the advanced settings tab, we just go over to the monitoring. As you can see, it's kind of high already. CPU package close to fucking 57 degree. That's cause it's still fucking 1.457 volts. This is totally dumb sometimes, not gonna lie. First thing we do is the CPU Q fan disable. Why I'm doing this? When I do this and you use the right pins on your main board, sorry, on the motherboard, that's the way you just let those fans you're connected there go with the highest, so with the highest spin rate they have. I'm always doing this. You hear this now? It's not loud because that's are nocturus. That's 3 of them pushing the air through the radiator of the CPU, and you can see it. The temperature will decrease now. Also, you can see the water pump and the I/O pump also disabled. That's kind of good because ASUS knows or sees that they are connected, and disable is always the highest, as I said, the highest voltage and so the most energy. So you have a high current into those fans, and that's what you want. Keep in mind some of your PVM, so of your 4 pins on the main board for the control of your pump, of the flow controller, of your some fans or whatever, are low current, and some are high current. If you're using like a switch for 3 or 4 fans, just go on a secure side and take a high current 4 pin on the main board, and just to be secure, or to be sure that this PVM control, or in general the pins you're using and the place on the main board is capable of driving them all with the real voltages and current they really need to work good and to spin up fast and have a very high spin rate, you know. So I know it's not possible to, like, I have like 14 nocturus inside here. It would be not possible to connect them all by single, so you just manage them. And some of you say, yeah, but I have on the back plate, I have those management, this and that. I just seeked out this one. This is from my Asus Extreme, and as long as it's not a real powered one, which is like with an real external power connector and a real USB control, so you have a real good external power source with more than 12 volt or with 12 volt and a high current, don't do this. Those ones who built into your 150, 200 US dollar or euro tower, they're mainly or mostly not good. On high ends, they're okay, but don't do it. Just stick with your mainboard, motherboard settings and use the control. One thing we're also doing here now is we're going for the Q-fan tuning. Why we are doing this? As I told you, we are used all those PVMs or PVM slots pins on the mainboard. This one is a good way for the mainboard to see how the capabilities for current and voltage is and how it behaves. So just by see how high the resistance on the slot is, they know how much voltage to current they need to power them to have the right amount of spin and the spinning speed for those fans. That's what we're doing right here. It will take a little bit of time. Last time we thought, okay, it's finished in 10 seconds, but I can take a drink in the meantime. So it's set now, and Q fan control is on. I just disable my CPU again. Now we go to the chassis fan controls, and you see it's all on auto, and then the chassis fan profile is on manual. So the numbers for the percentage and temperature is set by hand, or can be set by hand. You can just, I just go the easy way with turbo, set the minimum fan speed, low fan speed to 600 RPM, and then I just do this. What does it mean? It means after the fans are spinning up, cause there's a higher temperature, they stay or like idle like for 51 seconds in the higher RPM mode before they going down again, just to avoid that basically like 3 or 4 short high loads behind each other are raising the temperature this much that your system may crash. I just keep it like 51 seconds to idle at a higher RPM. That's kind of good. It's in Germany we say Vorlauf or Nachlauf. No, it's a Nachlauf. So it's like yeah, after, I don't know. I don't know how to call it in English, but you just keep them a little bit up for a longer time, and that's awesome. It just works. Just go with turbo here. 51 seconds again. I just do this for everyone, for all of them now. I now feel how the warm air, which was like nearly 60 degrees already, is coming out, and the temperature will go down and down and down. It's kind of good. Now I feel how it's getting colder already. That's the effect of that what we have done right here. Please don't go too conservative or too low with those rates, or in general with the cooling. If you don't have a super nice cooling system, very good high quality radiator, fans, whatever, just keep it a little bit higher. Just keep it minimum 50-60%. Why? You just want to have it already running at this stable temperature. Your system, the whole system, should be run at a good stable temperature, which is not that high. I try to avoid 60 degrees on the system in general. I try to avoid 60 on the CPU and on the GPU, and it works. And I can tell you this is very good, and feels very good, because those thermal throttling of frequencies is very common, and it's setting in very early, not when it's 80 or something. It starts on a way earlier point. And also a good cooling prevents you from jitters in the voltages and in general in the behaving of your whole system. So as we can see here on the overview is like that we have like 2600 RPM on the IO pump. Then we have 2.3 on those chassis fans. We have 2000 on the fan, on the CPU and on the CPU optional. That's it. Temperatures will decrease now. It's 45 now. It will take some time. Then we go over to the boot configuration. You just disable fast boot, please. Why are you doing this? Because you don't need this. I go full screen here, and it's better for you when you restart. It's better for you to apply settings in the BIOS later. It's just way better, believe me. For emptying cache, for registries, for everything, just disable. CSM, you should go for disable. Why? Because you're just using Windows. CSM is okay, and enable CSM is only if you use a system which is not UEFI, but you're using Windows, and that's UEFI. You go here for Windows UEFI mode at the OS type. That's totally good. Boot option is good. Native is good. So basically that's it here. Yep, we go on tool. We just go others memory create. We just go disable. Thank you. Graphics card information, no need. And by the way, you need to disable CSM if you want to use the resize bar. If you enable it and you use CSM, resize bar will not work. So that's it. We just go over to tools. We disable memory create. We've done already. That's it. See, we flashed the BIOS already. It's 4004, one of the latest, or the latest basically for me, in my opinion. That's it, guys. We just do this. You see, we have done a lot of changes. You can watch all your changes here again. what you disabled, what you have set, everything here. You see it's kind of long. We just go OK, and now the computer is done. It will explode in 3, 2, 1. Oh no, it's working. Shit. I'm kind of lucky the settings are working. Was first time. No, all good. Just take some time now to see the monitor again, because I still use those throughput method. Kann ich nicht aussehen? Let me check something. I think. Hold off. Disable. I changed something wrongly with my water pump. Need to save changes and reset again. Now it works. We just restart, then we go into Windows. Just to show you that Windows is loading with the settings. And then it's basically it, guys. It's like there's, for BIOS, you can try these settings for yourself. These settings will basically only work all together. Some of them may work if you use PBO and Curve Optimizer, but honestly, just by latencies and how my basic understanding of the work of circuits and signals is that stable voltages, stable clocks, in general totally stable settings which are not introducing latency, so they are not switching on any point, will help you to maintain the same latencies the whole time. So the behaving of your system in games is always the same. This helps you to perform better, to find a work point where latency, FPS max or FPS average is on a working point which is really enjoyable for you. The input latency is low, and that's what we have done right here, right now, on the very first part of my low latency guide, and low latency guys also. And basically with this setting and a G-Sync monitor, G-Sync Ultimate, those 360 QNR, you are capable with this G Pro Superlight to reach 6.2 milliseconds in click to photon latency if you want to. I can do it on my system, on my specs, and I think other people will do this or can do this too. It's rebuildable. I already know some people in my Discord who rebuild this and also have like 51, 52 nanoseconds, for example, on the memory throughput bench in latency on AIDA. So no problem. It's totally reliable, rebuildable. There's no like, but my clock needs to be this. You can do it even with 4.4 on both CCX. It works. For now, I have to say thank you for watching. That was part 1. Maybe we do this for Intel later when we get our Aqua OC and I put some time into this to make those low latency researches. I saw those latencies there are really high. I tried to lower them below 60, maybe below 50. Let's see what I can do. If you want to see more like this, please leave a sub. This will become a series. I hope the next parts will be way shorter than 1 hour now. And thanks you for watching so far. I hope you enjoyed it, and I hope it helps you to enjoy your gaming and your PC way more than you did before. All facts I've told you here and what I was talking about are researched by myself. I researched a lot, I read a lot, and I tested a lot. And also I tested a lot with LDAT to just see how my settings or my tested settings are reliable and reflectable in latency, in FPS, in smoothness and stutter in games, and in general behavior. So this is not what I think it's good. This is what I've proven myself works the best for me. I hope it works the best for you too. Thanks for watching, guys. If there are any questions or you think I'm just a motherfucking dumbass, just tell me in the comments below, guys. See you on the next video. Bye.